smaller 25% and the bigger 75%. Then we have quartile 3. Quartile 3 is breaking up the bottom 75% and the top 25%. So that's how quartile 1, quartile 3 work, is essentially just dividing the data set into quarters. So to kind of show that as a picture, here is the picture. So right here you have quartile 1, right here you have the median, right here you have quartile 3. So if you notice, quartile 1 is breaking up the bottom 25% of the data set and the top 75% of the data set. Same thing for quartile 3. Quartile 3 is over here. It's breaking up the bottom 75% of the data set and the top 25% of the data set. So once we find quartile 1, quartile 3, you kind of have to just know that it is breaking up the bottom and the top percentile. Any questions so far in regard to quartile 1, quartile 3? All right. So these are the steps that we're going to be using in order to find the quartile. So the first thing that you want to do, always you want to arrange the data set from lowest to highest. So that's the step 1. So you get the data set and you have to arrange it from lowest to highest. Once you arrange the data set from lowest to highest, you want to determine what the median is, because the median is actually going to help you break up the data set into 2 equal groups. All right, so step 3 says divide the data set into half, the observation below to the left of M and the observation above M. So the first quartile is the median of the bottom half, and the third quartile, quartile 3, is the median of the top half. And then once you find those, we're also going to find something called the interquartile range, where the interquartile range is just quartile 3 minus quartile 1. So those are the steps that we're going to use in order to find these quartiles. Any question in regard to that so far before we actually move on to a problem? All right, so let's do a problem. All right, so here is our data set. So what we want to do, we want to get our data set, and what we want to do, we want to find the median. We want to find quartile 1, we want to find quartile 3, and we also want to find the interquartile range. So if you're on the first step that you want to go ahead and do is is first arrange them from lowest to highest. So let's do black. So the lowest number that we have is 1. So we put 1. All right, so we only have 1. So the next number should be 2. So we have 1, 2. Yeah, 1, 2. So then you want to see if you have any 3. For this one, we don't have any 3. It doesn't look like we have any 4s either. You do have a 5. So we put 5. So then you look for 6. If you look at it, there's no 6. So where you go to 7. 7, there's 1, 2, 7. So then you want to look for any 8s. So we have 1, 2, 3, and that's it. 1, 2, 3. Then you have 9. So you have 1, 9. And then that's pretty much it. You have a 10. You have 1 of those. Then you look for 11. So 11, you have 1, 2. Then you have 12. Then you have 15. Then you have 17. You have 2 of those. Then you have 18. You only have 1 of those. And then lastly, you have 219. So that's our data set. So that's our data set arranged from lowest to highest. Everybody good so far on lowest to highest?
Yes, sir.
All right, so the first thing we're gonna go ahead and do, we're gonna go ahead and find the median. So remember the median is the number in the middle. So if you kind of remember from last time, we just cross them out. And you keep on going until you either have 1 or you have 2 numbers in the middle. All right, so if you look at that one, we have 2 numbers in the middle. So if you remember, whenever we have 2 numbers in the middle, in order to get the median, we add those 2 numbers and then you divide it by 2. So if you do 9 plus 10, you get 19. 19 divided by 2, you get 9.5. And that's our median. But that shouldn't be anything new because we already knew how to find the median from the last class. So what we're gonna go ahead and do, right now we're gonna break up our data set into 2 different halves. So you're gonna have the lower half, which have the lower number, and you're gonna have the upper half, which have the bigger number. So if you look at it right now, since we have 2 numbers in the middle, the way that you're gonna actually divide it, you're gonna divide it where this one goes with this group, and this one goes with this other group. And now you have 2 different halves. And like the way that you can kind of tell if you're doing this right, every time you have your 2 groups, these should have the same amount of data set. So if I look right here, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at both of my group have 10. So that's how I know I divided up the data set into 2 equal halves. If one group have more than the other, you did something wrong to it because it should always be the same amount of data set. Any question in regard to that before we move on to Q1 and Q3? All right, so to find Q1, what we're gonna do, Q1 is the median of the lower half. So it could be the median of my, of my yellow group. So right now what I'm going to go ahead and do, I'm gonna go and get focused on the yellow. And for this one, we're gonna find, oops, sorry about that. We're gonna find the median of the yellow group. So I'm gonna cross this 1 out, cross out this 9, cross out this 2, cross out this 8, cross out this 2, cross out this 8, cross out this 5, cross out this 8, and you get those 2 numbers in the middle. So same thing, what we're gonna go ahead and do, you're gonna take the average, so you go 7 plus 7 divided by 2, and you get 7. So that's quartile 1. Any question for quartile 1? All right, let's do quartile 3. So quartile 3, now I'm going to focus on the blue group. So on the blue group, we will cross out the 10, cross out the 19, cross out 11, cross out 19, cross out 11, cross out 18, cross out 12, cross out 17. And you get these 2 numbers in the middle. So once again, since you have 2 numbers in the middle, you take the average of those 2. There you go, 15 plus 17 divided by 2, and you get 16. So that's how we find quartile 3. You focus on the half that has the bigger number, and the median of that half will be my quartile 3. Any question in regard to quartile 3? All right, lastly, we're gonna do the interquartile range. So the interquartile range, all you have to do, you got to get Q3 and subtract it from Q1. So Q3, if you look at it, is 16. Q1 is 7. So if I do 16 minus 7, you get 9. So you get IQR is equal to 9. And we're all done with this problem. Any question in regards to how I got anything in this problem? All right. So let's go on to the next problem. All right, so we're gonna go ahead and do this next problem. So for this next problem, what we wanna do, we wanna find pretty much the median, quartile 1, quartile 3, and we also wanna find the interquartile range. So there should be a subtraction sign there. So first thing we wanna do, we wanna look at our data set. And if you look at our data set, is the data set already arranged in order? Well, if you look at the data set, yeah, the data set is already arranged in order. So what we're gonna go ahead and do, let's go ahead and find the median. So we cross out this one, 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 cross, and you find your median. Median is 18. All right. Everybody good on how I found the median? All right, so for this, you kind of have to know the difference between this one and the last problem. On the last problem, we had two numbers in the middle, and the way that we broke it up to two equal groups, one of the number went to the left side, one of the number went to the right side, and that's how you get the two equal group. But whenever you have one number in the middle, essentially what you're gonna do, you're just gonna ignore the number in the middle. So we're gonna ignore this one. And what we're gonna do, we're gonna say this is our lower half, and this is our upper half. So whenever you have one number in the middle, essentially you exclude that number, and then you look at the number to the left of it, that's your lower half. The number to the right of it, that will be your upper half. Right, any question on how we divided this data? Alrighty. So let's go ahead and you start crossing out. So cross out the 10, cross out the 17. I'm left with these two numbers. So if I do 13 plus 14 divided by 2, you get 13.5. Cool. And that's quartile 1. Now, if I do the same thing for the blue, well, sorry, for the yellow half group, I cross, I get these two numbers in the middle. So you go 27 plus 29 divided by 2. Oops, that's an ugly 2. And you get 28. Everybody get where the 28 come from? All right, so I got quartile 1, which is 13.5. I got quartile 3, which is 28. So the last thing I'm gonna go ahead and do, find the interquartile range, which is Q3 minus Q1. So you have Q3, which is 28. You have Q1, which is 13.5. So if I do 28 minus 13.5. Cool, thank you. They get 14.5. And we're all done with this problem. So like the whole point of this is for the quartile to break up the data set. Okay, if you look at quartile 1, it's 13.5, is right over here. If you look at the median, it's at 18, so it's right over here. If you look at quartile 3, it's 28, which is over here. Oops. So if you look at it, you have two numbers here, you have two numbers here, you have three number here, and you have two number here. So with the quartile trying to do, you're trying to divide up the data set where you have equal amount of data set for each quartile. So if you look at it, if it's an odd amount, it's kind of hard for it to be an equal amount because since there's an odd amount, there's always going to be one extra data set. But usually when it's an even amount, it kind of divides the data set up pretty nicely. All right. Any question in regard to this last example? All right, so let's try on the next example. So the next example will be a little bit bigger value. All right, so for this one said the paper total data study statistic on element results for Food and Drug Administration, April 25th, 2000 gave information on sodium content for various type of food. 25 tomato capsules were analyzed and data consistent with summary quantitative given in the paper were. So this is how much sodium each capsule had. So what we're gonna go ahead and do, if you look in the bottom, is to compute the value of the quartile and the interquartile range. So the first thing what we wanna look here is, we wanna see, is the data set in order?
Yes, it is.
It is. Yeah.
Oh, perfect. So the data set is already in order. So what we want to go ahead and do, we kind of want to go ahead and find the median first. So what you want to do here, this one's a little bit different because since you actually have row, and if you look at each row, it has the same amount. Because the first one has 5, second one has 5, third one has 5, fourth one has 5, this one has 5. So for this one, you can actually eliminate rows. So if I cross out this row, that means you cross out this row too. If I cross out this row, that means I cross out this row. And then you could go, I cross out this number, you cross out this number, I cross out this number, you cross out this number. And now the number in the middle is 11,040. So that's my median. So we'll say median is equal to 11,040. You do kind of want to use a little tricks whenever you can. So whenever you see like a bunch of data set and each one of them have a row and each row has the same amount, instead of canceling out the number one by one, what you could do, you could cancel out the number by how many rows you have. All right. Everybody go with that?
Yes.
All right. So if you kind of look at it, my data set is already divided into my two halves. So that's my lower half. And this is my upper half now. So right now we're gonna go ahead and do, we're gonna just go ahead and get our lower half. So for the lower half, we cancel out this number, we cancel out that number, cancel out this, cancel out that, cancel this number, cancel out this number, cancel, 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 and we're left with these two numbers in the middle. So let me highlight it for you for that way it make it a little bit more easier to see. So we're left with those two numbers in the middle. So if I want to find quartile 1, which this is, all we have to do is add them and then divide by 2. So if we add those two numbers and divide by 2, what do we get?
10,452.
Cool. And let me double check that. Cool. All right, and that's quartile 1. Any question in regard to how we did quartile 1? All right, so what we're gonna go ahead and do, we're gonna do quartile 3. So for quartile 3, we'll do exactly the same thing. We'll cross, 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 cross. And you get these two numbers in the middle. So this is going to be quartile 3. So for quartile 3, we'll say 11,778 plus 11,781, all divided by 2. And let's see what does that give us. And if you do the math, you get 11,779.5. And that's it for quartile 3. Any question in regard to quartile 3? All right, so lastly, what we're gonna go ahead and do, we're gonna find the interquartile range, and that'll be it for that. So let me actually change this to black. So for the IQR, you get Q3, which is 11,779.5, subtracted by 10,452. So if you do that, you get 1327.5. And that's it for your problem. So you should know how to find Q1 and Q3. And once you find Q1 and Q3, that should help you find IQR, because IQR is just taking Q3 and subtracting it from Q1. All right, so those are your quartiles. Any question in regard to quartile before we move on to something else? All right, so let's go to the next slide. All right. So the next slide is how to check for outliers. So remember, outlier is just any number that are kind of far away from the data set. Because I'll kind of imagine, like in a test, everybody scored in the 80, and then we have one student who scored, like say, in the 20s. So the 20 will be an outlier because since everybody's scoring 80, it's kind of like an outlier for somebody to score that low. So anytime we're looking for an outlier is any like abnormal data set that doesn't really fit in with the other data set. So I'm gonna go over how to mathematically show if there's an outlier. So the first step that you wanna do is determine the first and the third quartile of the data set. So you wanna find what Q1 and Q3 is. Once you find what quartile 1 and quartile 3 is, what you want to go ahead and do is find the IQR, and the IQR is equal to Q3 minus Q1. So pretty much what we just did in the last 3 problems. In order to determine if something is an outlier, what we have to do, we have to find the lower fence and the upper fence. So the lower and the upper fence is kind of just telling you like, these are the lowest and this is the highest our number could be. Anything higher than the upper fence or anything lower than the lower fence will be considered an outlier. So to find the lower fence, you get Q1 minus 1.5 times the IQR, and the upper fence will be Q3 plus 1.5 times the IQR. And the 1.5, that's a part of the formula, is a constant. That number is never gonna change. So once you find the lower fence and the upper fence, what you want to do, step 4, if a data value is less than the lower fence or greater than the upper fence, it's considered a potential outlier. So that's how we're going to check for outliers. Any question in regards to that so far? Actually, no. All right, so for this one said, check the data on the speed of vehicle traveling through a construction zone on a state highway for potential outlier. So here's all of our data sets. So the first thing what you have to always do, look at the data set. If you're looking for the median, quartile 1, quartile 3, you always have to check to see if the data set is in order. So if you look at our data set, is the data set in order?
Yes.
Yeah. All right, so up next, we're gonna go ahead and do, we're gonna go ahead and find the quartile. So we'll cross this, cross this, cross, 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 cross. All right. So we find, we'll put it right here, median is equal to 33. So now what I'm going to go ahead and do, I'm going to break up the data set into two data sets. So the number to the left of 33 and the number to the right of 33. So those are my lower half and my upper half. So once you find your lower half and your upper half, what we're going to do, we're going to find the median of those halves. So we'll cross out 20, 32, 24, 30, 27, 28, or 29, and we get 28 as quartile 1. Then we're going to go ahead and do, we're going to now look at the neon green color. So that one will cross out 34, 61, 36, 40, 38, 40, and you get 39. All right, so far I found my median is 33, my quartile 1 is 28, quartile 3 is 39. Any questions so far for any of those values? All right, so up next we're gonna go ahead and do, we're gonna go ahead and find the IQR. So remember, IQR is quartile 3, minus quartile 1. So quartile 3 is 39, quartile 1 is 28. If you do 39 minus 28, we get 11. And actually, let me bring this down, so that way you can see it a little bit better. All right, so we get median is 33, we get quartile 1 is 28, we get quartile 3 is 39, and lastly we get IQR, which is 11. Everybody good with those numbers so far? All right, yes. So now we're gonna find the lower fence. So the lower fence will get Q1 minus 1.5 times the IQR. So what we're gonna do, we're gonna get Q1. Q1 is equal to 28 minus 1.5 times the IQR, which is 11. So first you wanna do 1.5 times 11. So 1.5 times 11, and that's 16.5. So you get 28 minus 16.5. If you do 28 minus 16.5, so what was it? 28 minus 16.5, you get 11.5. So that's my lower fence. So that's telling me in order for somebody to be considered an outlier in speed, they have to be going below 11.5 mile per hour. So they're going like 10 mile per hour. So LF is equal to Q1 minus 1.5. That's my lower fence. That's gonna calculate like what the lowest my number should be. So that's what the LF stand for. It's telling us this is the lowest value it could possibly be before we consider it to be an outlier. All right, so we get LF is equal to 11.5. Any question on lower fence is equal to 11.5? All right, let's get the upper fence. So for the upper fence, we get Q3 plus 1.5 times the IQR. So we're gonna get Q3, where Q3 in this case scenario is 39, added to 1.5 times 11. If you do 1.5 times 11, you get 16.5. So you get 39 plus 16.5. So lastly, if we do 39 plus 16.5, you get 55.5 for my upper fence. So my upper fence is telling me any number higher than 55.5 are considered to be an outlier. Because if somebody is going like 80 mile per hour or 70 mile per hour or 60 mile per hour, that's too high, because my upper fence is saying the highest it could possibly be before the outlier is 55.5. So anything higher than 55.5, we're gonna say that's an outlier. All right, so we have our lower fence, which is 11.5. Do we have any number that's lower than 11.5?
No.
Oh, perfect, thank you. What about, do we have any number higher than 55.5?
61.
Yeah, 61. So for this one, we'll say 61 is a potential outlier. And that's how you want to check for outliers. So in a quiz or in a test, if it ever asks you check for a potential outlier, this is the process you want to go through to be able to check to see if you have any outlier. Any question for the last problem?
So the potential is anything under the, what do you call the Q1 and Q3? Like anything lower or higher?
Anything lower or higher than the lower fence and the upper fence.
Okay.
Yeah, so that's why we're using, well, that's why we're finding the lower fence and the upper fence, because the lower fence and the upper fence are gonna tell us like what the lowest it could possibly be or what the highest it could possibly be. But yeah, you want to use the lower fence and the upper fence.
Okay. Thank you.
Yeah, you're welcome. Any other question? All right, let's scroll on down. All right. So I'm going to go over a definition. So the definition is just the definition of a five number summary. So a five number summary is just five number that summarize the data set. So for us, the five number summary you gotta contain is right over here. So if you look at it, the first thing that a five number summary should have is the minimum, because the minimum is telling us the lowest number we should have. The next one that we're gonna have is quartile 1, and then followed by medium, and then followed by quartile 3, and then followed by the maximum. So in a test or in a quiz, if I say, give me the five number summary, all I want you to do, give me these five numbers. So it'll be the minimum, quartile 1, medium, quartile 3, and the maximum. Any question in regard to what a five number summary is? All right, so up next we're gonna go ahead and do, we're gonna go ahead and draw a box plot. So to be able to draw a box plot, the box plot, we're gonna use the five number summary. So we use the five number summary, and once we get the five number summary, we want to check to see if any of those data set are outliers. So the step that we're gonna use is the first step. You wanna find the lower fence and the upper fence. Once you find the lower fence and the upper fence, what you want to do, you want to check to see if you have any outlier. So once you check for any outlier, what you want to do, you want to go to step number 2, where it says draw a number line long enough to include the maximum and the minimum value. And then it says insert a vertical line at Q1, medium, and Q3, and close the vertical line in a box. So this one is pretty much saying we're gonna get a box, and the first is Q1, then the medium, and then Q3. So when we do the box portion of the box plot, the box portion of the box plot, it is showing Q1, medium, and Q3. All right. So then for step number 3, it says draw a line from Q1 to the smallest data value that is larger than the lower fence. Draw a line from Q3 to the largest data value that is smaller than the upper fence. These lines are called whisker. And then step 4, if any data value less than the lower fence or greater than the upper fence are outlier and marked with an asterisk. So if we do have any outlier, you have to just mark them with an asterisk, because since they are outlier, you kind of want to show in the box plot that you do have some outlier. All right. So any question in regard to that before we actually go on and do a problem? All right, so let's do a problem. All right. So for this one, we have 85, 92, 97, 100, 70, 60, 85, 95, and 90. So if you look at the instructions, it says find the find number summary, construct the box plot, and check for outlier. So first thing we want to go ahead and do is make the data set from lowest to highest, because if you look at the data set, it's not from lowest to highest. So we'll say, oops, sorry about that. So we'll say 60, we'll say 70, then we get 85, then we get 85, then you get 90, 92, 95, 97, and 100. All right, so that's our data set arranged from lowest to highest. So what we're gonna go ahead and do, we're gonna go ahead and just find the median. Once we find the median, we're gonna find quartile 1, quartile 3, and then we'll get the find number summary. So let's go ahead and find the median. So you cross, 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 and we get one number. So we'll say the median is 90. Everybody good that the median is 90? All right. So if you look at it, we have our lower half and we have our upper half. So I'll highlight my lower half in green and my upper half will do it in yellow. So what I want to do, I want to go ahead and find Q1. So Q1 will cross, cross, and you get these two numbers in the middle. So to get Q1, you get 70 plus 85 divided by 2. And let's see what does that give us. So we'll say 70 plus 85, now divided by 2. And you get 77.5. Everybody good where the 77.5 come from? So let's go ahead and find Q3. So we'll cross 92, 100, and we get these two numbers in the middle. So we'll say Q3 is equal to 95 plus 97 divided by 2. And this will actually be 96. So for our 5-number summary, it will be 60, 77.5, 90, 96, 100. So that's your 5-number summary. The 5-number summary should always contain the minimum, quartile 1, median, quartile 3, and the maximum. Any question in regard to the 5-number summary?
No.
All right. So let's go ahead and find the lower fence and the upper fence. So for the lower fence, Well, let's actually find IQR. To find IQR, you do Q3, which is 96, minus 77.5. So if I do 96 minus 77.5, you get 18.5. So that's my IQR. So to find the lower fence, what we're gonna do, we're gonna get Q1, which is 77.5 minus 1.5 times my IQR, which is 18.5. Right. So we do 77.5 minus 1.5 times 18.5, and you get 49.75. So that's my lower fence. So telling me in order for something to be considered a outlier or a potential outlier, it has to be smaller than 49.79. So somebody score like in the 40s or in the 30s or in the 20s, those numbers will be considered outlier because it's too low. So up next, we're gonna go ahead and do, we're gonna go ahead and do the upper fence. So the upper fence, we get Q3, which is 99, plus 1.5 times 18.5. So let's say, oops, should be
For the upper, isn't it 96? Oh.
Yeah, thank you. Yeah, so it should be 96, not 99. So you do 96 plus 1.5 times 18.5, and you get 123.75. So for the upper fence, if you look at my upper fence, it's telling me in order for somebody to be considered an outlier, pretty much they have to have score above 123.75. So they got like 130, 140, 150. Those will be considered outlier because those numbers are bigger than my upper fence. All right. Everybody good for the lower fence and the upper fence? All right, so the last thing we're gonna go ahead and do, we're gonna construct the box plot. So for the box plot, what you wanna do, you wanna first do a vertical line, a horizontal line. And for the horizontal line, it should be able to fit the minimum and the maximum. So if you look at the minimum is 60. So we're gonna start off at 60, and then we're gonna go to 65, 70, 75, 80, 85, 90, 95, and 100. So if you look right there, I stop at 100 because that's the highest number we have. You're not gonna go any higher than 100 because the max is 100. All right. So first thing we wanna go ahead and do, we first wanna go ahead and do our quartile. So I'm gonna do quartile 1, the medium, and quartile 3. So if you look at quartile 1, it's 77.5, which is somewhere over here. So that's quartile 1. If you look at quartile, well, if you look at the medium is at 90. So it'll be somewhere over here. And lastly, if you look at quartile 3, the 96, so that's somewhere over here. So we're gonna connect these and connect these. And I'm gonna just label them in test or quiz. You don't have to do this. I'm gonna do it right now for that way you know what each one of these are. Okay, so you got Q1, medium, and Q3. Everybody good with that? All right. So up next, what we're gonna go ahead and do, we're gonna go ahead and do the whisker part of it. So the whisker, if we don't have any outlier, you essentially just go from quartile 1 all the way to the minimum. So if you look at our data set, for our data set, we have no outlier. So we have no outlier because if you look at it, we don't have any number smaller than 49.75, but also we don't have any number higher than 123.75. So since that's the case, we're gonna say we have no outliers. So when we're doing our whisker, for this one, we're gonna do our whisker all the way to our minimum. So we're gonna do a whisker all the way to 60. And if you look at for the other whisker, we're gonna do a whisker all the way to our maximum. All right, and we're done. So that's our box plot with no outlier. So that's how you want to do a box plot if you have no outlier. So if you look at it, all you have to do, you find the 5-number summary. And then once you do the 5-number summary, you're going to do the box plot using that 5-number summary. All right, but any question in regards to that box plot? All right, so let's go ahead and do the next box plot. All right. So for this box plot, I'm just letting you know this one already gonna have an outlier. So for this one, I'm gonna show you how to do a box plot with an outlier. For that, we can see the different without an outlier and with the outlier, because it does change the box plot. So for this one, says every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the U.S. The following data are the interest rate charged by 10 credit card issuer randomly selected for the July 2017 survey. So it says construct a box plot of the data set. So here's our data set. So for this one, we're gonna keep it as a percent. We're not gonna change it as a decimal because it should be easier to keep it as a percent versus changing it to a decimal. So for this one, if you look at the data set, is the data set already arranged from lowest to highest?
Yes.
Yeah, so the data set is already arranged from lowest to highest. So let's go ahead and find the median. So to find the median, we're gonna cross them out. So if you look, we get these two numbers. So in order for us to find the median, we're gonna get 13.90 plus 0.3, and we're gonna divide this by 2. So if we get 13.90 plus 13.3, and then you divide that entire thing by 2, what do we get? And if you want, you can also put it in the chat if you already did the math.
$13.55.
Not 55. Or was it?
13.6.
Yeah, there you go. There you go. So yeah, so it should be 13.6. So what we're gonna go ahead and do, we're now gonna find quartile 1 and we're gonna find quartile 3. So to find quartile 1, we're gonna use this data set. And to find quartile 3, we're gonna use this as our data set. All right. So let's go ahead and find quartile 1. So cross, 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 cross. And here's quartile 1. So cross, 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 cross. That's quartile 3. All right. Everybody get how we found quartile 1 and quartile 3? All right, so the last thing we're gonna go ahead and do, we're gonna find the IQR. So for the IQR, here, let's actually just move all of this over here. So to find the IQR, what we want to do, get Q3 subtracted by Q1. So if I do Q3, which is 14.4 minus 12, what's 14.4 minus 12?
2.4.
2.4, perfect, thank you. All right, so let's go ahead and let's find the lower fence and the upper fence. So for the lower fence, we're gonna say Q1, which is 12, minus 1.5 times 2.4. So let's see what does that give us. So let's say 12 minus 1.5 times 2.4. And you get 8.4. So that means if we have any number lower than 8.4, they will be considered outlier because anything below 8.4% will be considered an outlier. So if you get 7, if you get 6, if you get 5 as an interest rate, those values are considered to be too low and these should be considered to be outlier. So let's do the upper fence. So for the upper fence, we get Q3, which is 14.4 plus 1.5 times 2.4. So you get 14.4 plus 1.5 times 2.4, and you get 18. So if you look at my lower fence, if you look at my upper fence, they're telling me any number between 8.4 and 18 are considered to be normal. But if the number is higher than 18 or lower than 88.4, we'll consider that to be an outlier. So based off of that, do we have any potential outlier in our data set? Like, are any of these data sets considered to be potential outlier? And if so, which one?
We don't.
So we don't see any potential outlier?
6.5.
There you go. So the 6.5, that one will be considered a potential outlier. So let's say 6.5% is a potential outlier. Cool. But if you look at it, that's the only potential outlier that we have. So we're all done with that one. Any question in regard to the last problem? Okay, so let's go ahead and do our box plot. So if you look at the box plot, you always want to start off at the lowest number. So that's 6.5. So let's start off at 6.5. And let's jump up by 0.5. So we'll say 7, 7.5, 8, 8.5, 9, 9.5, 10, 11, oops, 10.5, 11, 11.5, 12, 12.5, 13. All right, so we'll start off at 6.5 and we end at 15 because we're stopping at 15. Well, we actually could have stopped sooner because the highest number that we have is 14.5. All right. So the first thing what we want to go ahead and do, we're going to go ahead and do the quartile. So we're going to do quartile 1, medium, and quartile 3. So quartile 1 is 12. So 12 is over here. So that's quartile 1. Then what we want to do, we want to do the median, which is 13.6. which is over here. So that's our median. Lastly, we have quartile 3, which is 14.4, which is over here. So then what you want to do, connect the dots, and we're going to make a box. So that's how you do the box portion when you have outliers. So if you look at it, the outlier doesn't affect your box. The box should still remain the same. All right. Everybody good so far with the box portion? All right, so up next, if you look at it now, what we want to do, we're going to do the whisker. So to be able to do the whisker, you want to go ahead and see the max. So for the max was 14.5, and remember that wasn't an outlier. So we put 14.5, and that's it for that one. Like 13.5. But no, it's not 13.5, it's 13.6. Okay, if you look at our median was 13.6, so you put 13.6 there. Did that answer your question about why 13.5? All right. So up next, we're gonna go ahead and we're gonna do the whisker to the left. So for the whisker to the left, we go to the minimum, but for this case, the minimum is an outlier. So for 6.5, oops, sorry. We're gonna put an asterisk right here, or a star. So 6.5 is an outlier. So you put something to symbolize that is an outlier. So I put 6.5 and I put a star right there to signify that value is a potential outlier. So now what I want to go ahead and do, I want to now go ahead and look for the next lowest number. So what's the next lowest number?
9.90.
9.90. So what we're gonna do the whisker, but we're gonna do the whisker to 9.90. And that's it. So whenever you do have an outlier, you still have to have the whisker portion. So to determine what how far down your whisker is gonna go, you have to see what the next lowest number is. In case if your max is an outlier, you look for the next highest number. So you're always looking for either the next lowest number or the next highest number. All right, but that's it for that one. Any question in regard to the last problem? So let's scroll on down. All right. So based off of the shape of the box plot, you can kind of tell if your data set is going to be either symmetric, skewed to the left, or skewed to the right. So if you look at this one, like the one thing you're always looking for, you're looking at the whiskers. If you look at both of these whiskers for the symmetric, what do you notice about both of their whisker? Are they the same length, or is one bigger or the other one bigger?
It's to the left.
Well, but don't they kind of look the same though? Well, so whenever you have symmetric data, for symmetric data, both of the whiskers should be kind of like the same length. Because if you look at the red one, which whisker has the longer whisker? The left side or the right side?
Left side.
Left side. And that's why this one will be considered skewed to the left or skew left. If you look at the blue box plot, which one's longer, the left side or the right side? Well, if you look at the blue box plot, the right side have a longer whisker. So for this one, it will be skewed to the right. So that's how you can use your box plot to kind of determine the shape of the distribution. So you can just look at it and go like, okay, since the left whisker is longer, we're gonna say it's skewed to the left. If the right whisker is longer, you're gonna say it's skewed to the right. The only time that's not true is if you have an outlier. If you have an outlier, whatever side the outlier is on, that one's automatically gonna be skewed to that side. So if you have an outlier to the right side, you're gonna say it's skewed to the right. If you have an outlier to the left side, you're gonna say it's skewed to the left. So what we're gonna do, we're gonna go look at the last two previous box plot, and you're gonna tell me if it's skewed to the left, skewed to the right, or symmetric. All right, so what about this box plot? Would this box plot be skewed to the left, skewed to the right, or symmetric?
Skewed to the left.
Due to the left.
You left, perfect. All right, what about this box plot over here?
Skew to the left.
Skewed to the left, perfect. And skewed to the left because we have an outlier here. But also if we didn't have the outlier, you could kind of clearly see this whisker is longer than this whisker, so that way it's skewed to the left. All right, and that's the box plot. Any question in regard to box plot? Okay, so I'm gonna show you something on ClassCal. For that way you can always double check your answer on ClassCal. So let's see. All right, so right now you should be seeing ClassCalc. So I want to show you first how to get the fine number summary using ClassCal, and I'm also going to show you how to do a box plot for the box plot for your data set using ClassCal. So for this one, I'm going to use the data set for the percentage for the credit card. So I'm going to say A is equal to, I'm going to put all of the percentage. So I'm going to put 6.5, comma 9.9, comma 12, comma 13, comma 13.3, comma 13.9, comma 14.3, comma 14.4, comma 14.4, comma 14.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. If you look at it, I have 10 data sets. If you look at a ClassCalc right here, put 10 element list because there are 10 numbers right here. All right, so once you put the 10 numbers, let's go ahead and use ClassCalc. So first I'm gonna show you how to get the fine number summary. So you might want to take notes on how to get there. Not that hard, but just for that way for the future you can memorize it. So first thing you want to do, you want to hit the stats button. And for this one, what you want to go ahead and do, hit the advance. So once you go to advance, if you look right here where it says 1 bar stats, here, let me do something. You want to click right here where it says 1 bar stats. So you do 1 bar stats. Oops. Not meant to do that. So we go stats, we go to advanced, and we hit 1 bar stats. Everybody go on 1 bar stats. And for the 1 bar stats, it should be on a new row. Okay, everybody's good. So what I wanted to do, I wanted to find the fine number summary of this data set. So I'm going to put A. All right. So if you look right here, it gave me the minimum. It gave me the minimum of 6.5. It gave me the medium of 13.6. It gave me the max of 14.5. It gave me Q1 of 12. And it gave me Q3 of 14.4. If you also look, it also gave me the median. Well, sorry, it also gave me the mean of 12.64. All right. But that's how you get the 5-number summary using ClassCalc. So if you ever want to double check your answer, you can always use the 1-bar stat to give you the 5-number summary. Any question on the 5-number summary? All right. So up next, we're gonna go ahead and do the box plot using ClassCalc. So to do the box plot, you go to Stat, you go right here to Distribution/Plot. And if you look right here in the bottom where it says box plot, you want to press that. So press box plot, and then you put A again. So if you notice right now, it's not showing absolutely nothing because it's not focused at that area. In order for us to be focused on that area, if you look right below my red dot, there's a magnifying glass. So you want to press that magnifying glass for that way it could zoom in on my box plot. So let's tell it to zoom into the box plot. All right. So if you look at it, this is our box plot, but if you notice, it's not showing any outlier. So the reason it's not showing any outlier because I didn't tell it to show outlier. So what I wanted to do, put it right here where it says exclude outlier. And now it's gonna show you the outlier. So it's gonna show you the outlier, which is 6.5. It's gonna show you, and it'll show you the box plot for you. All right. And that's how you want to double check your answer for the box plot. So if your box plot doesn't look like the box plot that ClassCalc is giving you, more likely than not, you did something wrong and you want to double check your answer. Any question in regard to how to use ClassCalc to double check your answer? All right, so let's go back to the notes. We have one more thing to do, and then I'll let you work on the activity. For today's activity, there are actually 3 activities for today's lesson. So for today's activity, you're doing 4A, 4B, and 4C. All right. So up next, we're gonna go ahead and we're gonna work on something called a box. Sorry, not a box plot. We already did the box plot. We're gonna do something called a dot plot. So a dot plot is essentially a dot. So you put multiple dots on top of each other if you have numbers that repeat. So if you look at this one, we have 2 dots on the number 2. So that means you have 2 that occur twice. You have this one where you have 3 dots. So that means you have 3, 3. You do have a quiz today. Remember, the quiz today going to cover what you learned on Thursday. And I'll tell you which quiz you have to do. So that way, if you forgot which one it is. All right. So if you look at this one, you have a 4. So that means you have 1, 4. You have a 5, 1, 5. And you have 2, 7. So for a dot plot, essentially you put a dot for whichever number repeats. So if you have multiple numbers that repeat, or if you have a number that repeat, you put a bunch of dots on that depending on how many times it repeats. All right, so let's go ahead and do some example. All right, so for this one saying a survey question asking how many siblings do you have these results. So right here telling you how many siblings do they have. And right here, telling you how many people said they had like 0 sibling, 1 sibling, 2 siblings, so on and so forth. So if we look at people who have 0 sibling, which is over here, how many people said they had 0 sibling?
3.
Yeah, 3. So that means we're gonna put 3 dots. So let's actually use something better. How many people said they have 1 sibling?
3.
Yeah, 3. How many people said they had 2 siblings?
3.
3. All right, and then you have 6 people who said they had 3 siblings. And then you have 4 people who said they have 4 siblings. 1, 2, 3, 4. You have nobody who said they have 5 siblings. And lastly, you have 1 person who said they have 1 sibling. Well, 6 siblings, sorry. And that's it for that dot plot. Any question in regard to that dot plot? Okay. So let's go ahead and do this last dot plot and we're done. All right, so for this one, so let's construct a dot plot for the amount of calorie contained in 36 different Ben & Jerry flavor. So for this one, we have 36 different Ben & Jerry flavor, and what we're gonna do, we're gonna create a dot plot for it. So if you look right here, we have 210. So we're gonna put a dot right here at 210. If you look at 220, we only have 1 220, so we put a dot right here at 220. Right here, we have 2 numbers at 230, so we go 1, 2. You have 1 number at 240. You have 1, 2, 3, 4 number at 250, so 1, 2, 3, 4. You have 1, 2, 3, 4 numbers at 260, so you go 1, 2, 3, 4. You have 1, 2, 3, 4, 5 at 270. And then you have 1, 2, 3, 4, 5, 6 at 280. 1, 2, 3, 4, 5, 6. Then 290, you only have 2, so 1, 2. 1, 2, 3, 300. And 310, you have 1, 2, 3. 330, you only have 1. 350, you only have 1. 360, you only have 1. And 490, well, you only have 1. So that's your box, oh, sorry, that's your dot plot. So if you look at the dots, it's not that hard. Each dot on top of each other just means how many times that particular number repeat. So if you have a number that repeats like 5 times, you're gonna do 5 dots on top of each other. All right. Any question for this dot plot?
No.
All right, sweet. So by looking at the dot plot, how many flavor ice cream have 300 or more calorie?
Six.
I see more than 6, because 300 is over here. Okay, if you look at it, it says 300 or more, so that means we want to include the 3.
10.
Yeah, so you get 10. So you get 10. So that's it for A. So then for B, it said what percent of Ben & Jerry flavor ice cream had 300 or more calorie? Well, we know we have 10 Ben & Jerry flavor ice cream that had 300 or more calorie, but since we want to find the percent, you divide it by the total. So the total is 36. So you go 10 divided by 36. It's 0.27. And the 7 actually repeat itself. So we're going to put 7 bar because that represents that the number repeat itself. All right, lastly, are there any Ben & Jerry flavor ice cream that are unusually low or high in calorie? So looking at this, do we have any number that kind of jump out at you? Well, the number that should kind of jump out at you is this one over here. Okay, if you look at it, if you look at compare that to the other Ben & Jerry flavor ice cream calorie, you have a huge gap between this one, the next highest one. So for this one, we'll say 490. Okay. Sweet. All right, and that's it for that one. Any question in regard to the last prong? All right.
No.
Question?
No, I was just saying no.
Okay, cool, thanks. So let me go over and I'm gonna show you pretty much what you're gonna have to do today. All right, so for today you're gonna do 3 activity. So I'm gonna show you which 3 activity you wanna do. So if you click right here in activity, so the 3 activity you wanna do today is activity 4A, activity 4B, and activity 4C. So for this one, you're gonna have to do these 3 activity. I'm gonna post up the solution today for these activity. So that way, once you're done with these activity, you can kind of double check your answer by looking at the solution that I posted up. So these are for the activity. For the homework for today that you're able to do. So right now for the homework, hopefully you should have finished all of chapter 1, sampling and data. And you should all be in chapter 2, descriptive statistic. So if you go to descriptive statistic, so far you should hopefully have done organizing and graphing of data, measure of center, and you want to do this one for today homework assignment. So you want to do measure of position. So this is the homework you should be working for today's lecture. And lastly, let's go over which quiz you're gonna take today. So for the quiz, you should click right here. And for today's quiz, you should be doing quiz number 3. And quiz number 3 is pretty much gonna cover what we went over on Thursday, which should be the measure of center. So you click on quiz number 3 and just do that. And for quiz number 3, you're gonna be open all the way from 11:30 a.m. today, all the way to 10 p.m. So if you wanna take it right after class, you could do so, or if you wanna take it at 9:30 p.m., you could go ahead and do so and take the quiz. All right, but pretty much that's everything that we did for today. Any question about any of the activity, quizzes, or homework? Okay, so what I'm gonna go ahead and do, I'm gonna go ahead and split you up into groups of 3. For that, we can start working on activity 4A or B or whichever one you're working on. And then I'll kind of jump around. Like we only have 11 more minutes, so try to get as much done, and whatever you can do, just kind of leave that for later on today. All right, so right now you should all be getting an invitation to go to a room. So once you get the invitation, join that room. And here, let me see if I could get today's activity.
and welcome to this class calc tutorial. Today, a graphing calculator is packed with powerful features like linear equations, polynomials, polar and parametric functions, restrictions, calculus, and anything else you'll need to explore math. Today will be a general walkthrough, so make sure to check out our other videos for a more in-depth look at specific features. Let's start with a linear equation. Hello, and welcome to today's class calc tutorial on frequency lists. A frequency list is a function that takes in the values in one list and multiplies their frequency by the values in another list. For example, if I grab the frequency list function and type 1, 2, 3 in the first list and 10 and 20 in the second list, I'll get an output of 10 ones, 10 twos, and 20 threes. To use this list, I can set it equal to a, and then use a in any function, such as 1 var stat, or a histogram.
All right, class, so I kind of messed up. I forgot to go over one thing on class calc. So I'm going to show you that by using the pretty much by using activity number 4. So let me share activity number 4A with you. So I'm going to do number 1, and we're going to do 1B. So calculating the pi number summary. So if you kind of notice, it give you the score, then I give you a frequency. So I didn't really go over how to do that. So I'm going to show you how to do that using class calc. So it shouldn't take that long. So to do this in class calc, what you want to do, you want to go to the stats button. Once you go to the stats button, you go to advanced. And let me move this thing out of the way.
We can't see it.
You can't see class calc?
No.
Okay, here it is. Let me share. Let's share the screen. All right, so now you should be able to see class calc. So what you want to go ahead and do, you want to say A, oops, you want to say A equal, and then right here you want to go where it says stats, you want to go to advanced, and if you see right in the bottom where it says frequency list, so you want to put frequency list. So for L1, you're going to put the number, and L2, you're going to put the frequency. So if you look right here, the score is 10, 20, 30. So I'm going to put 10, comma, 20, comma, 30. And then if you look at 45, 95, 95, 99. So 45, 95, and 99. So you put that into L1. And then for L2, we're gonna put the frequency. So for the frequency, if you look at it, it's 565,311. So 565, so 565, and then 311. And then you put 3, comma, 1, comma, 1. So that's your frequency list. So now what we're gonna go ahead and do, we're gonna go to stats, we're gonna go to advanced, and we're gonna do a 1 bar stats. And then what you're gonna tell it, you're gonna tell it to look at the data set. That way we set it equal to A. And it will give you the 5 number summary. So here goes the minimum, here goes the medium of 20, here goes the max of 99. Quartile 1 is 15, quartile 3 is 37.5. So that's how you wanna do it. If you have your scores and if you have a frequency, so you always want to use, which one is it? The frequency list. So you want to use the frequency list, you have to tell it that you have a data set that has frequency. So that's how you want to do activity number 1. Well, 4A, sorry. All right, any question in regards to that?
I have a question about 1A, sorry.
Yeah.
So when you're looking for the mean, median, and mode, are you looking at the score or frequency?
You're looking at the score, but you have to use the medium you have to use the frequency in order to do that. So if you kind of go back to Thursday lecture, if you go back to Thursday lecture, I actually went over how to find the mean, median, and mode for this. Like for the mode is the easiest. You just look at the frequency. The one that has the highest frequency is your mode. So in this case, 20 will be your mode.
Okay.
Okay.
Okay, thank you.
There we go. Any other questions?
For the mean, you just add up all the scores and then divide it by the number there are, right?
Correct. But before you do that, you have to multiply the score by the frequency. So you have to do 10 times 5. So you have to multiply these two. And then you multiply these two. Then you multiply these two. Then you multiply these two, so on and so forth. And then you divide it by the total amount of frequency.
Got it. Okay, thank you.
All right, so I'm gonna close this down. If you do have further questions, you can always drop on in my office hour. I'll be in the office hour pretty soon. So I'm gonna close this one down, and that way if you do want to jump onto the office hour, you could totally do that if you have any question that you still have about either today's lecture or yesterday's lecture. Any question before I close this down?
No.
All right, I'll see everybody tomorrow.